Okay, let's do an example so that we can kind of take a look and see what I'm talking about in like the real world of a problem. So in this case, an opinion poll asks a sample of 500 adults and SRS whether they favor giving parents of school-age children vouchers that can be exchanged for education at any public or private school of their choice. Each school would be paid by the government on the basis of how many vouchers it collected. Suppose, in fact, that 45% of the population favors this idea. Okay, so now we're going to walk through and look at every one of these questions. What is the mean of the sampling distribution? Okay, so in this case, the mean is my center. This is a proportion. The reason I can tell it's a proportion is I got a p hat here. So what it's asking me is the following. I need to know what is the mean of all those p hats. Well, again, the mean of all those p hats equals the true proportion of stated random. Well, in this case, it says SRS. That means random. So the mean of all those p hats is equal to the true proportion. The true proportion, only one in there, that 45%, 0.45. And it's because an SRS was taken. Because it was random. We've verified random. We can verify center. Okay. Now the next one. The next question is going to ask about, sorry, is going to ask about what is the standard deviation. So what it wants is the standard deviation of p hat. That's going to be this formula, p 1 minus p over n. But this is only if we can verify if it was independent. So what we're going to do is we're going to do this independence check. And that's 10n less than or equal to big N. Is that a true statement? So we need to know sample size. My sample size is 500. N equals 500. So I'm going to do 10 times 500. That equals 5,000. And in this case, what's the population I'm talking about? I'm talking about adults. So this is just adults. Is it safe to assume there's more than 5,000 adults? I'm going to say, yep, it's safe to assume more than 5,000 adults. So what that means is I'm now allowed to use this formula. So what I do is I go ahead and I plug in my values. My p is 0.45. 1 minus 0.45 over 500, or yeah, 500. And that tells me that my standard deviation here is going to be 0.0222. So a little over 2%. So my variability here is about 2%. The next one, can you use the normal approximation? Is the shape normal? And the way we check that is we need to do NP. And in this case, N 500, P 0.45. 500 times 0.45 is 225. That's greater than or equal to 10. So these are my successes. And 1 minus P. So 500 times 1 minus 0.45. That's going to equal 275, which is also greater than or equal to 10. This is tracking my failures. So since I have 10 or more successes and failures, I can tell you that the shape is approximately normal. So these are all the checks I got to do. I got to write this down and prove it. So yeah, I got to prove it. I can't just say approximately normal, standard deviation, and then this, I have to say why. So now what this whole point of this is the following. I now have a normal distribution here, normal distribution, centered at 0.45 with a standard deviation of 0.0222. So now what this means is the following. I can now go ahead and draw myself a curve. I can go ahead and I can put down a normal curve. What I can now do is I can figure out all the numbers to put on here. Mean goes in the center, 0.45. And then what I can do is I can pick, I can go ahead and figure out what those plus and minus 3s are. So the pluses are going to be relatively easy. This is going to be 0.4722. The next one is going to be 0.4944. And this last one is going to be 0.5166. And then if I want to go ahead and subtract, I got to break out the calculator because I can't do that in my head. 0.45 minus 0.0222. And this is going to be 0.4278. 0.4056. 0.3834. So now what ends up happening is the question says, what is the probability that more than half of the sample are in favor? So what does more than half mean? More than half means 50%. So this problem is asking me, what is the probability that I can go ahead and get a p hat that is larger than 50%? Well, if we look down here, 50% is going to be right about here, and this area right here. So there's my p hat of 0.5. So now what I'm trying to figure out is like, is that a realistic number? What I'm going to do is, easiest way to do it is I'm going to go to, in my calculator, normal CDF. The 4 arguments are your lower bound, your upper bound, your mean, and your standard deviation. So in this case, my lower bound, I want it to be at a minimum of 50. Upper bound, I don't have one, so it's 99999, lots of nines. My mean is 45. My standard deviation is 0.0222. I type that into the calculator, and what's going to happen? 0, 1, 2, 3. It's saying the probability of me finding more than half the people supporting my idea are just a little bit over 1%. So it's not very likely. So if I was a politician and this was something that I was investigating for my constituents, I wouldn't necessarily waste too much time on it, because really it seems highly unlikely that in a sample of 500 people, I would find a majority who supported this idea. If you look at this majority of the time, it's actually going to be below that 50%, like not over 98% of the time. The same idea holds for means, but what you would do is when you went through the checks, this check here would be the same. You're checking random. This check here would be the same. You're checking 10n. However, you use a different formula for standard deviation. The shape check is different, and I say this every time. You check successes and failures for proportions. You check the shape of the population or the sample size for means. It's 2 different checks. You can't just use one all the time. So hopefully that'll help. I would suggest you just do the practice, like I said in class. The way you're going to get this is by practicing. You're not going to get it by watching my videos. You're not going to get it by just listening. You're going to get it by putting the pencil on the paper. So hopefully that helped.